OSU at the Hatfield Center, and because of the Marine Mammal Stranding Network that's part of that, both of which involve our presenter tonight, Markus Horning, we were able to mobilize a crew that was allowed entry into that cave to free that sea lion, who went on to, we assume, good health afterward and was rescued successfully. As you'll hear from tonight's presenter, that's one of many dangers facing pinnipeds along the U.S. West Coast and in other waters these days. Markus Horning has been with the Marine Mammal Institute for several years now, where he studies stellar sea lions, how seals age, and he's currently developing new devices to remotely monitor the movements and habits of these animals as they move around their habitat to find out exactly what's taking place in their world. The Marine Mammal Institute of OSU has been much in the news over the past year for the great work that they've done, the different very high-profile film projects that they've been involved in. We're very fortunate at OSU to have the Marine Mammal Institute and the wonderful scientists who work there. Perhaps none better than tonight's presenter, Markus Horning. Markus?
All right, let's see. A little bit lower. Okay, can you hear me all? Everybody? Sounds good. Well, good evening, and it's a pleasure to be here. Thank you.
I'm just going to do this.
Okay, thanks. Yeah, and actually, if you wouldn't mind giving the light here a little bit, that'd be great. So, thanks for the introduction, Todd, and thanks for the opportunity to talk about my work at the Marine Mammal Institute in Newport at the Hatfield Science Center. And what Todd didn't mention was that my academic career is kind of a little bit of a story of rags to riches, in that when I started as an undergraduate student at UC San Diego many years ago, I was a physics major having nothing to do with the animals that we'll be talking about tonight. Instead, I looked at all sorts of physical matters, and by chance got a job as a pool cleaner cleaning seal tanks at the Scripps Institution of Oceanography. And that's actually how I got involved in studying these animals that I've been studying for about 3 decades now. And maybe I should add that RAGS does not refer to physics as a subject matter, but to cleaning seal tanks, basically. So, before we get to talking about what this talk is primarily about, and that is threats to seals and sea lions in our changing oceans, I figured I should give you a little bit of an idea of what these animals are really like. So here's some basic background facts on the biology of pinnipeds. And pinnipeds, as you might have gleaned from the trivia questions that we just looked at, are comprised of seals, sea lions, fur seals, and walrus. Seals are also called the true seals or earless seals, and comprise harbor seals and elephant seals, and can be recognized by the fact that they don't have any external ears, as opposed to sea lions and fur seals, which have little horn-like ears. You can almost kind of see that on this particular stellar sea lion down here. And they're called the eared seals. And finally, walrus also are part of the pinnipeds. But I'll mostly be talking about seals and sea lions, and we're looking at about 35 or more, depending on how you count, species of pinnipeds that are globally distributed and can be found in all oceans of the world. From the smallest, the Galapagos fur seal, which is a very small pinniped with adult body masses ranging from about 40 pounds for adult females to about 140 pounds for adult males. So from the smallest species on the Galapagos Islands to the southern elephant seals, which is literally the behemoth amongst pinnipeds, with adult females weighing about 800 pounds on average and adult males 10 times as much. So that's basically, you're looking at a UPS delivery truck in terms of mass and size, and a loaded one at that. So you can find them in all oceans of the world, but pinnipeds are also quite tied to solid substrates, so to shore-based or ice-based haul-out locations where they breed and mate and lactate and suckle. And that's why these animals are actually quite visible and accessible to us, but why there are also quite a few opportunities for interactions with humans, which may be to their detriment, as we might find out later. And finally, to fill you in on some of the basic facts about their biology, pinnipeds are very diverse in terms of the diet, and you can find pinnipeds that will feed on fish, on shellfish, on squid, even on birds and mammals. In the case of the leopard seal, for example, in the Antarctic, that is known to prey on penguins, or stellar sea lion moles up in Alaska that prey on either very young sea lions or on harbor seals, for example. You've also gleaned that these animals are quite amazing performers and in fact are capable of dives up to 1,700 meters or in excess of 5,000 feet. And that's been logged on northern elephant seal females. And they're also capable of remaining submerged on a single breath for more than an hour and a half in the case of Weddell seals. So just to give you an idea of what that really represents, imagine taking a deep breath, holding your breath now, and not breathing again until you go home later. And in fact, not just that, but to perform a comparable feat, we'd have to put you on a treadmill the entire time without breathing. That's what these animals are capable of, so quite amazing. It's also amazing on a distinct scale when you consider the migrations of northern elephant seals. And in fact, northern elephant seals are one of the very, very few mammals that undergo twice a year biannual migrations from Central California, where they congregate to meet, to breed and lactate and molt. And from there, they range all the way to the Bering Sea, a distance of 4,000 kilometers one way. And they do that twice a year. They come back to breed, and they come back later again to molt. When you add to that the vertical displacement that these animals go through on each and every dive, because they spend a significant, in fact, the majority of their lives at sea, diving to great depths, you can easily tally up about 20 to 40,000 kilometers of swimming distance every year for these animals. And that would be the equivalent of circumnavigating the globe every single year. So quite an amazing performance. And finally, just to round up a little bit of information and trivia about the biology of these animals, they also sport a very diverse lactation strategy. And what you might have seen there was the listing of Galapagos fur seals, again, as you remember, the smallest species, which typically wean their offspring at the age of about 2 and sometimes even only 3 years. And that means they have a very extended period of dependence of young on their mother's milk, up to 3 years. And that's quite distinct from some of the other animals that are at the other extreme. And in particular, the northern Arctic ice seals, like hooded seals and harp seals, are capable of reaching enormous growth rates for their pups, in part because they have milk fat content up to 60%. So more than half of their milk is grease, essentially, and that's compared to about 4% of cow milk. And at that level of energy content of mother's milk, pups can grow to weaning weight within about 4 to 8 days. So that's quite distinct from what the Galapagos fur seals are capable of. So, any thoughts? Here we go. So as that machine is warming up again, what pinnipeds can you encounter along the Oregon coast? Again, part of the trivia questions. And there are 3 species of pinnipeds that actually breed along the Oregon coast, and that would be the harbor seals, the stellar sea lions, and the northern elephant seals. Not many people are aware of that. They actually do breed at Cape Arago, although in very small numbers. There are typically only 5, 10, at the most 15 pups born every year at Cape Arago, and the majority of those probably do not survive.
Can you say where that was again?
That was at Cape Arago, near Charleston, Coos Bay. So down in southern half of Oregon. And of course, you also do see large numbers of California sea lions. But California sea lions don't breed along the Oregon coast. They breed, in fact, in California. And what you see here are males that show up outside of the breeding season when they desert the breeding areas in central and southern California and Baja California and migrate up north. And in fact, that's what we see in this particular image. After I should catch up and tell you that also we do have very rare visitors in the form of northern fur seals and Guadalupe fur seals, but those are pretty rare occurrences along the Oregon coast. And of course, they don't breed here. So this picture, in fact, was taken just last December of 2009 at Heceta Head, so just south of here and near Sea Lion Caves, and shows an unusually large congregation of California sea lions in one bay just next to the Heceta Head Lighthouse. Now, per se, it is not unusual to see a large number of California sea lions in these areas in wintertime, like December or January, because that's when the males show up here and when they've left their breeding grounds. But what was unusual about this event was the sheer number, and we counted anywhere from 5,000 to 8,000 animals on this particular beach at that time. And in addition to the sheer numbers, we also saw, quite unusually, a fair number of relatively small and young animals and females even. And this is related to very unusual oceanographic conditions in central and southern California. And those unusual oceanographic conditions resulted in reduced prey availability for these animals and their displacement to northern regions like here in Oregon. But basically, this image also does illustrate, even though it is an unusual event or related to an unusual event, what you also might have gleaned from the trivia quiz earlier, and that in fact the numbers of California sea lions along the entire west coast of the United States have dramatically increased over the last 3 to 4 decades. And we're looking at an increase from less than 10,000 individuals about 40 years ago to almost 300,000 individuals of California sea lions along the west coast. And in fact, California sea lions are thought to be near carrying capacity along the west coast. And we'll get back to that term and what that means a little bit later. It's not an isolated phenomenon when we're considering different pinniped species. In fact, when you look at harbor seals, and because they're resident, I'm showing you the numbers for Oregon and Washington together, their numbers have also steadily increased over that same time frame of about 3 to 4 decades. Not quite as dramatically as the California sea lions, but still, we're seeing an almost threefold increase to close to 40,000 animals. And again, the increase has leveled off because these animals are thought to be near carrying capacity along the northern west coast of the United States. So, a fairly consistent picture in our waters here and along the California current system. But a very different picture is what we'll be looking at next. And so let's travel up to Alaska and in fact to Segwam Island. Segwam Island is in the Aleutian Island chain, so it's on the border between the North Pacific and the Bering Sea. And this picture was taken, again, about almost 4 decades ago in July of 1970, and you're looking at a large number of stellar sea lions populating this particular beach about 4 decades ago. If you go back to Segwam Island now, this is what you would be looking at. This is an aerial photo of the same beach taken in July of 2007. And what do we see? We see what looks like a few boulders there, but those boulders are in fact not boulders, but are male adult stellar sea lions. And the stellar sea lions, as I should point out, are the largest of the eared seals or otoliths. They're huge animals, with males weighing up to about 2,500 pounds, females considerably smaller, about 600 pounds. And July, in fact, is their reproductive season. July is the peak of the breeding season when the males typically defend territories, and that is what we're looking at here. The males are defending territories along this beach that formerly used to be quite busy with not just males, but also females that were breeding, pups that were born, and young that would show up. But nobody's here. So what happened? Where have all the animals gone, except for the males? Well, what you're looking at here is a graph that is showing us the population of the stellar sea lion over the past 3 to 4 decades. And over this time frame from 1970 to about now, the total counts of stellar sea lions in western Alaska, that comprises the Gulf of Alaska and the Aleutian Islands and the Bering Sea, have declined from about 170,000 animals in 1970 to approximately 45,000 animals now. So this is a huge decrease over this time frame. Now remember, this is the western portion of the stellar sea lion. What has happened here along the Pacific Northwest coastline at the same time? The counts of eastern stellar sea lions, including Southeast Alaska, British Columbia, Washington, Oregon, and California, at the same time have increased dramatically, and in fact have just about, or have more than doubled, and have surpassed the total counts of western stellar sea lions. So a very distinct population trend in terms of what we're seeing here from what we're seeing up in Alaska. This phenomenon, however, is not isolated, not restricted solely to the stellar sea lion. In fact, in this particular graph, you're looking at 3 species of pinnipeds and also sea otters. and their population declines in central and western Alaska. So that's the central Gulf of Alaska and the Aleutian Islands. And basically from the 70s, about here, to about now, the populations have declined, even though to make them visible on the same scale, they're portrayed here as percent of maximum abundance. And so you're looking at a significant drop in sea lions, sea otters, northern fur seals, and harbor seals. In fact, this has been called by some a sequential population collapse of pinnipeds and sea otters in the Alaska, North Pacific, Bering Sea region. So that is unusual, to say the least. And it is unusual because we're looking at species that inhabit very distinct habitats. The northern fur seal, for example, is primarily to be found on the Pribilof Islands in the middle of the Bering Sea, even though it ranges widely from there and travels extensively. The sea lions are found along the Aleutian Islands mostly. Harbor seals are found along the Aleutian Islands, Gulf of Alaska, Southeast Alaska as well, on different types of substrates. And of course, sea otters are the most near shore of these animals, foraging also on very distinct prey species. So all of these animals inhabit distinct habitats and forage on very different prey. Urchins, for example, versus a variety of different forage fish for these pinnipeds. What these species have in common, however, is a common predator, and that is the transient ecotype of the killer whale. So killer whales have been documented to prey on all 4 of these species. That is something they have in common. Still, what changed to create this decline? Killer whales have been around for a long time, just like all these pinnipeds and the sea otters have been around. Something must have changed, really, to prompt this initial and continuing decline. Well, some scientists, in fact, have considered that killer whales, or transient killer whales, formerly preyed primarily on the great whales. And what is shown in this particular graph here is the harvest biomass of the commercial harvest of the great whales in that same region. So you're basically looking at an increase in collection of great whales through the 60s and up until the 70s, which then declined because of the international whaling moratorium. But some researchers, like Alan Springer and collaborators, actually suggested that this harvest of the great whales forced transient killer whales to switch from their primary prey, the great whales, to alternate prey, and they basically munched their way down the food chain through less desirable prey items, including popcorn-like sea otters, basically. Well, is that a very consistent picture? Not entirely. You need to be a little bit more careful and look at this at your depth. What you're looking at here is the same type of change in British Columbia on the left portion of the graph for only 3 species of those 4, excluding the fur seals because they don't typically range that far south. And we look at a very different pattern over the same time frame, 1980s through 2000. So a dramatic increase at the same time. Yet, when we're looking at the great whale biomass removal, the pattern in British Columbia is very similar to the pattern that was observed in Alaska. So that sheds some doubts on the idea that this decline in Alaska may have been caused by predation by transient killer whales, and that in turn that might have been triggered by the demise of the great whales. So let's examine this a little bit more closely. But basically, what I'll be talking about for the next portion of my presentation is this discrepancy in population trends in different species and different regions, and how can we possibly explain that? What might that be related to? Well, let's start with a little bit of a primer on population ecology. What drives population trajectories? It's really a very simple answer. Population trajectories are largely driven by productivity in relation to mortality. Productivity in this case is not primary productivity, but productivity of the species of interest. So the sea lions. The productivity of sea lions, let's start with that, is really the number of pups that are born, what we refer to as natality. How many join the group versus mortality, which would be how many leave the group. So how many animals join the group? What are birth rates? Which vary, and we'll see a little bit how they vary. But however, in addition to actual number of pups born, we need to consider the life history of the species we're looking at, because Animals are weaned at different ages. They grow to sexual maturity through different time frames and become mature at different ages and begin to reproduce. And they have different lifespans over which they can contribute to the reproductive output of the population. In addition, we need to consider that the number of pups born or productivity is probably largely also driven by food availability, which in turn affects reproduction. Some females, if they can't get enough food, will simply not reproduce or may spontaneously abort. How much food there is may determine how soon an animal may get weaned and how rapidly it can grow and begin to reproduce. How about the other end of the spectrum, or the other side of the equation? So mortality. What contributes to mortality in the population? Well, predation. We already know that. I told you that killer whales are known to prey on some of these animals. But that's not the only source of mortality in some of these pinnipeds. Starvation, and again, that may be linked to food availability. If an animal can't feed itself, it's going to die. It's going to starve to death out there. Diseases may certainly contribute to mortality events, and in fact, it's been suggested, and you've probably heard, that there are increasing occurrences of harmful algal blooms, which may result in bioaccumulation of certain toxins through the food chain. Sea lions may ingest these and suffer from, for example, domoic acid toxicity, which may kill them in fairly large numbers. Marine debris, Todd mentioned that in his introduction, can be an issue along our coastlines here, which may directly kill some of these animals. But we also have subsistence harvest in some regions. In Alaska, still does occur on stellar sea lions and northern fursulas, for example. And we have takes for management purposes, like everybody's probably familiar with the takes of sea lions on the Bonneville Dam on the Columbia River. So another source of mortality. And finally, we have incidental mortality related to industrial and commercial activities like fishery, unintentional mortalities from ship strikes. Certainly our research projects that I'll be presenting, we need to consider the possibility we're having an impact on these animals. And of course, there may be environmental calamities like oil spills, which may also kill these animals. So basically, what we're looking at is two sides of the equation that drive population trajectories: production or productivity on one side, mortality on the other side. And the question then that naturally arises, where is the problem in the regions where we're seeing declines? You might have also heard of the terms top-down effects versus bottom-up effects. And that refers essentially to what we're looking at here, effects that are working through productivity versus effects that are working on mortality. So basically, bottom-up effects are resource-driven effects, largely in the context of food availability, whereas top-down effects are largely mortality, or, for example, predation and incidental mortality effects. But I put this versus here in quotation marks, and that's to make the point that this is a debate that is often centered around discussing one versus the other, top-down versus bottom-up, or productivity versus mortality. And that's a very unfortunate turn of events. I'll let you folks be the judge of how appropriate that might be after I'll introduce you to a few more concepts in this context. So there is an implicit assumption that when we're talking about declines and the relationship between productivity and mortality, we're really talking about threats on seals and sea lions in relation to changing oceans or challenged oceans. So let's talk about some of these threats and how they might act on the two sides of the equation here. And for starters, of course, there is food availability and an alteration in food availability, which may occur for any of a number of reasons. So, for example, we can assume that fisheries removes a large amount of fish biomass from the oceans, and that might be in direct competition to some of the seals and sea lions. It might remove some of their prey. But fisheries aside, there are other changes in the oceans that might impact food availability. You've heard about El Nino events, you've heard about the Pacific Decadal Oscillation, you've heard about regime shifts, and of course you've heard about changing climate and how that might be reflected in ocean conditions, including, for example, ocean acidification, which might make oceans less habitable to plankton, and primary productivity might be affected and decreased, and as a result, we might just see reduced food availability, for example, and we can conjecture that this will be reflected in the number of pups born because it will affect reproduction, weaning, and growth ultimately. However, we are looking at effects on the other side of the equation as well. Altered food availability can directly result in extreme cases in starvation, and can also, if it takes shape in the form of increased fisheries activity, for example, result in increased incidental mortality and increased ship strikes. And finally, there's also the possibility that animals that have to spend much more time looking for food to feed themselves are going to spend more time at sea and are going to be much more exposed to predators. So we're looking at effects on both sides. Please keep that in mind as we move forward and consider some other threats. So other prominent threats related to changes in the ocean that might affect pinnipeds, seals, and sea lions are, for example, pollution. And we know that certain pollutants affect the immune system and affect fecundity, or the number of females that become pregnant and ultimately give birth to a pup. So we can assume that pollution may have an effect on natality, and most animals in terms of their life history are typically not set up to deal with large amounts of pollution that affect their fecundity. However, we also, once again, are looking at effects on the other side on mortality. Severe pollution can cause diseases that kill animals outright, but can also affect their ability to assimilate food, resulting in starvation. Marine debris, finally, is a form of pollution that can also directly kill animals, and we'll talk a little bit more about that later. And HABs, or harmful algal blooms, again, can create mortality, but also affect the number of pups born because, for example, domoic acid toxicity can result in aborted fetuses in sea lions and reduced birth rates. And finally, one of the biggest potential threats, at least in relation to changing global and ocean climates, is habitat alteration. And that is most visible and most prominent probably for Arctic ice seals, ice breeding seals that are tied to ice for hauling out, for reproducing, for lactating. And so once again, you probably are looking at effects on both sides. Because of loss of haul-outs and